Good morning, Seeders. In this video we are going to go through a calculate question from the particle model of matter topic. In this question you can see it starts with a graph. So an electric kettle was switched on. The graph shows how the temperature of the water inside the kettle changed, and if you have a look at the graph, have a look at the y-axis, we can see that the temperature of the water, it doesn't start at 0, it starts at just over 20 degrees Celsius. That would be 22 degrees Celsius. And over a period of time, up to 100 seconds, the temperature of the water increases up to 100 degrees, as you would expect, because the kettle is boiling the water for a tasty cup of tea. In the question, we are told the energy transferred to the water in the 100 seconds was 155,000 joules. We are told the specific heat capacity of water is 4,200 joules per kilogram degree Celsius, and we are asked to determine the mass of water in the kettle. And we are told we need to use the graph above. So thus far in our calculate question, we don't have to do any conversions with the data we are given. Our energy is in joules, we have our specific heat capacity in joules per kilogram degree Celsius, our graph is in degrees Celsius. So no conversions required at this point. The equation that we are going to be using will be E, energy, is equal to M, the mass of the substance, multiplied by theta, which is the temperature change of the substance, multiplied by C, which is specific heat capacity of the substance. When we get to the method for using our equation, the first thing we must always do is substitute before rearranging, because you get credit for this stage. So we have 155,000 joules substituted for the E for energy. We have been asked to determine the mass, so we shall leave M as M. Theta is the temperature change, so this is where we must use the graph above. So let us go back to the graph. We can see the temperature of the water started here at 22 degrees Celsius and increased to 100 degrees Celsius. And so the temperature change of the water was 78 degrees Celsius, and the specific heat capacity of water is given as 4,200. Now at this point, I will always, let's go through step by step. I like to simplify before doing the rearranging. So we'll keep our 155,000. It's equal to M multiplied by, so at this point I would do the 78 multiplied excuse me, by the 4,200, giving us 327,600. Now we rearrange. So we're multiplying by the 327,600 on this side of the equals, so we'll be dividing 155,000 divided by 327,600 is equal to M. So if we do our 155,000 divided by 327,600, that gives us actually a number with quite a lot of decimal places. So that will give us 0.47313 and so forth and so forth. However, you will see we've been asked to give our answer to two significant figures. So this will round to 0.47. The unit for mass is the kilogram. I've put it in there because it is good practice, it is a good habit to do so. We remember our units in CEMU, but actually if you look at the question, the units are given. You will find a link to this question and the mark scheme in the link associated with the video. Thank you for watching. I hope you found this useful. Don't forget to subscribe. This is Mr. Rolf signing off.